This tutorial is about pipe sizing for a vented and wet steam condensate return. This is Mosabet. I'm a professional mechanical engineer with over 30 years of experience in HVAC and utility systems. According to ASHRAE Fundamentals Handbook, Chapter 22, there are 3 types of condensate return. The dry-close type, the vented or open wet type, and the vented or open dry type. The dry-close condensate return is the most common, mostly used in steam systems. I have a tutorial for pipe sizing for this type on YouTube. The vented dry type is less common for not being energy efficient. This is due to the venting and as a result loss of flash steam. I discussed the pipe sizing for this type in another YouTube tutorial. Today's discussion is about pipe sizing for the vented wet condensate return. This type, like the vented dry type, is less common, due to its energy inefficiency for venting and wasting flash steam. In a vented wet type, the condensate enters a vented pipe that is slightly above atmospheric pressure. The generated flash steam, due to reduced liquid pressure inside the pipe, is vented outside. The liquid condensate at close to boiling temperature fills the pipe and flows to the condensate collection tank. The driving force in this piping setup is the available liquid head, as shown here, that pushes the condensate forward. Sizing the pipe for a vented wet condensate return is easy. We can use either Table 36 in Chapter 22 of the 2017 ASHRAE Fundamentals Handbook or an online calculator. For either method, the first step is to calculate the total pipe length. For example, L equals A plus B plus C plus D plus E. The two lengths D and E are the equivalent pipe length for the elbow and for the T. I will have a tutorial for calculating pipe equivalent length for fittings and valves soon. Having the total length L, the formula below must be used to calculate the condensate head. The condensate head is in feet per 100 feet of pipe and is the allowed pipe pressure drop that makes the flow of condensate possible. Condensate head equals 100 times available liquid head divided by total length. For using the table to determine the pipe size, with the condensate head and the flow rate of liquid condensate known, the pipe size is selected in column 1 of the table. For example, for condensate head of 1.5 feet per 100 feet and liquid flow rate of 27,600 pounds per hour, a 4-inch pipe is needed. Using the online calculator is easier and more flexible. Let's go to Google and search for a website called papecalculators.com. I put together this site and it is available for free. I will leave the link in the description. Clicking on the link, the website opens. There are many different engineering calculators on this website. The calculator we are going to use is pipe sizing for vented wet condensate return. Clicking on the link, the page pops up. The calculator is good and accurate for carbon steel pipe and for saturated steam. It can be used in 2 different units, IP or inch-pound units and SI or metric units. Please note that the calculator does not adjust the input numbers when the unit changes from one to the other, using the drop-down for selecting IP or SI. Separate inputs are needed for each unit group. I will select IP units for this tutorial. To calculate the pipe size for a vented wet condensate return, 3 inputs are needed. Steam pressure in psig. Liquid condensate flow rate in pounds per hour. And the condensate head in feet per 100 feet of pipe. Note that the online calculator also calculates the flash steam flow rate that is vented outside. Knowing the flash steam flow rate helps in sizing the vent pipe properly. As an example, I will use steam pressure of 125 psig, liquid condensate flow rate of 5,000 pounds per hour, and a condensate head of 2 feet per 100 feet. The calculated data are a 2-inch pipe and flash steam flow rate of 877 pounds per hour. Note that based on the selected 2-inch pipe, the calculated condensate head, that indicates the minimum required, is 1.61 feet per 100 feet of pipe. If I select a pipe diameter of 1.5 inches instead of the condensate head, the required condensate head will be 5.74 feet per 100 feet. That exceeds our available 2 feet per 100 feet. To size the vent pipe for flash steam, let's go back to the home page and select the pipe sizing for saturated steam. Using steam pressure of 1 psig, flow rate of 877 pounds per hour and steam velocity of 5,000 feet per minute, the calculated pipe size is 4 inches. The calculated pressure drop is 0.12 psi per 100 feet of pipe. This calculator is very flexible and can be used to analyze the outcome of different situations by easily testing different inputs in its drop-downs menu. Let me know please by leaving comments if you have questions and/or comments for the online calculators and/or I can help you with this type of engineering design and calculations. I will get back to you. Thank you for watching.